Hello everyone, today I'll be explaining a C++ program that is designed to run a statistical analysis for students, course mark, listed in TXT file. This is the name for the file. It has 8 columns and 137 columns. It should be rows, I guess. So I'll be doing the first A, B, C, and D1. So what we have to do basically is that we have a raw txt file. It looks like this. It's just a raw file. There is a sequence, student ID, mark assignment, project, lab, test 1, test 2, and CV. There is coursework marks. So what we have to do for the first one is that identify percentage of students who obtain certain marks based on grade. Grading category is going to be A, B, C, and D. A, B, C, and F. So this is how our program looks like. We have preprocessed directives, and the important ones are F-stream. We are going to manipulate that. So we have an input file and output file so that we can open them. We have string and CMath, and here I have my function that I'm going to use for the manipulation of person. I'll explain that later. Here I have user-defined structure named as student data, and it includes sequence, student ID, mark assignment, mark lab, mark project, test 1, test 2, total marks. And here is our constant. It is size. It is 137 students. The 137 rows. So here is our variable names. So here is our student data is going to be arrow with the size of 137. And here what we do is that we initiate, we open file. I give a name as sample file. I'm going to open that, and I give a name students.txt. It is simple. It's going to be stored in desktop. So here we check whether that txt file was opened or not. If sample file.fail, it is going to see out that file open error, and it's going to be ended with error. And here what I do is that I have a looping. It is going to be looped until 137 as number of students. And what I do is that I get from sample file and store that data into my variables. For example, sequence, student, mark assignment, lab, and so on. Then I close my file. So closing file is very important. I should move it into the last. Here, I guess I have to. No. Yeah, I have to move it into the end of my file. So what we do next is that remember in our A question, what we have to do is that we have to get the marks and convert into them a grading category A, B, C, and F. So here I get all the marks and multiply them by looping each one to 10, so that we have 18, 19, and 100 system. Then here I increment A, B, and C with if-else statements. Then I count them. Here I open another file. It is going to be output file that I'm going to write into it. So I open it and name it students2.txt, and I'm going to write into that file by this shapes. It is used as cin. So here is my function. So what my function do is that it has two variables. It multiplies into 200 and divides by into the second variable, so that I have a percentage of how students do in their assignments. So here I have for assignment blah 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 percent of students got A, blah 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 students got B and C. Here is I have tab. So let's look how it looks like, my program. Let's compile it, compile and run. And see students.txt file. It's just the raw data, as I said. The students2.txt file is going to be statistical analysis. So it is basically here. For assignment, 29.9% of students got A, B, and the same stuff we do for labs, for project marks, for test 1 and for test 2. I'll show you. Here, we do the same thing for our lab marks. We use if-else statement. We use my function that I made for project, for test, for test 2. Until test 2, we do that. And then what we do, what our next exercise tells us to do, is that we have to identify percentage of students coursework mark by grading category. Refer category in part A. We do the same stuff. We do the same manipulations to our coursework marks. So test 1. Here we have our total coursework mark. We initiate A, B, C, and F into 0 so that we don't get error, and we use looping, and I have variable total marks, and we multiply it into 2 because the previous ones we multiplied into 10 because they hold 10% of the coursework marks, and the total coursework mark is going to be 100. So it holds 50%, so we multiply it into 2, so it has 100%. Then we use if-else statement to categorize them. So here I increment A's that they got, B's, C's, and F's. And then I see out A, B, C, D, just so that I can trace if that was correct or not. Then I write that information into my output stream file. So I say total course mark. Here I have my function so that I convert this A, B, and C's into percentage. Let's see how it looks like. So for total coursework mark, 30% of students got A, 62% of students got B, 5 C, and 1 F. Then our next exercise tells us that the C1 tells us that we have to get marks from test 1. Students who obtained mark below than 60 were called for intervention programs so that they can improve for next assessment. Identify how many students who undergone the intervention program percentage improved in test 2. So to do that, what I did is that I calculated how many students got below than 60. I just added C's and F's. Then for test 2, here for intervention, I have this. I use loop, and then I store the values of test 1 and test 2 into test 1 marks and test 2 marks, and calculate each marks into 10 so that we have that category from 0 to 100. And then I use if statement that says if test 2 marks is greater than or equals to 600 and test 1 marks is below than 59, then I'm going to increment E. The character E is just easy for use, so I see out E so that I can trace it. So here what I do is that I write that information into my output file. I say for intervention, I have my function, and into function I give values as E and 36. And what is 36 to us? And 36 is the number of students who got below than 60. So here, students who got below than 60, 36. Here we can see it is number of students who got A, it is 50, H6, 36, F, there is no F. Here I have the number of students who got for test 2, A, 62, 36, 23, and F, 18. So let's see how so then I write into my output file, as I said, the percentage of students who got improved by using my function, and then here is going to be just a new line. I'll show you how it looks like. So here, for intervention, 55.6% of students improve. Then I'm going to close it. Then what I do is I'm going to do the D1. In D1 we have to compare overall results of test 1 and test 2, and we have to analyze them by using mean, median, and standard deviation. We have to write the assessment statistical analysis into the students2.txt file. So it is how to do it. Firstly, we have mean. So what is mean is just an average. We are going to calculate an average. So we have a looping structure and a total sum variable and total sum 2 variable, and we are going to adapt each test marks into total sum and total sum 2. It is for test 1, total sum is for test 1, and total sum 2 is for test 2. Then we have our average AVE variable and AVE2 variable. We just divide the sum into the size, that is 137. And then we write to our output file a mean value for test 1 is going to be AVE, and mean value for test 2 is going to be AVE2, and the new line. So let's compile. We don't need that, and we'll open our students2 file, and here you can see for mean value test 1 it is 6.60, and for mean value test 2 it is 6.902. It's just a slight change. So then we do median. So we initiate variables like median test 1, and they are going to have value of 0 for now, and standard deviation 2, just deviation and deviation second. So median, here we have the formula for odd numbers. We got median test 1. First of all, we have to sort them. Then we have to divide the size, the length of our array, and divide it into 2 and add 1. So, and the number that is going to be in the middle of our raw data, that is going to be our median value. And the same stuff we do with this for the second one, and then I just write that data into the txt file outstream named as, so let's see, here we have our median value for test 1 is 7.62, median value for test 2 is going to be 9.5. Then we do standard deviation. So to calculate our deviation, here we have our formula. To use these formulas such as power and squared, we have to include CMAF. And then for deviation part, after we calculated everything, I just write our solution into output file. And then here I have if-else statement that is composed of our overall mean, standard, median, their assessments, like standard mean value for test 1 is greater than or smaller than, and here I compile all my files, and we will see how our output looks like. Overall outputs look out. And here it says standard deviation for test 1 is this, and the mean value for test 2 is greater than test 1, median value test 2 is greater than, and deviation value test 1 is greater than test 2. And then we have our statistical statement that says assessment with higher mean and median is the best. On the other hand, for standard deviation, the smaller value is better, and that's why test 2 is better than test 1. So that's all from me. Thank you for watching.
Hello, my name is Hanum Rahmanova, and the part I gonna present you is the last 3 tasks of our assignment number 2. So let's start. First task is identify a student who didn't take the assessment. First of all, we start with the declaration of variables, and we start our looping. So for each assessment, we will use individual looping. And so first of all, let's start from the assignments. So we start with the if condition. So if assignment will be 0, so the output will be the student ID. If, for example, all students submitted their assignments, so in the file we will see 0. So as you see, the same structure, the same procedures will go to all other assessment, for example for lab work, for project, for test 1, for test 2. Let's check how it works. So as you see, student who didn't do assignment 0, student who didn't do lab 2, we have 2 students with their ID, also 2 students who didn't do project, and 2 students who didn't do test 2. Test number 1, all students submitted. So next task is we need to identify students who scored below than 14, and then after that we need to list down the student who scored total coursework mark below than 40%. So again, we're starting from variables, and start looping using formula for identifying percentage of coursework out of 100 for each student. After identifying the percentage of each student mark, we use conditions, so to identify the percentage which is less than 40. And if there will be marks less than 40, it will be displayed student ID, the ID of student who got less than 40, the total coursework percentage, and total coursework. And now let's see our output. So here we are, student who scored below 40% for total CV and buried from final exam. We see 2 students who got less than 40. It's total coursework percentage and total coursework. And the last task is to create a new file which is called recommender.txt. This file will recommend the minimum mark that the student need to store to achieve the targeted grade. So we start with declaring our file. We use outstream as it is output file. We name our file as rec file and use the procedures that will help us to identify is the file work with errors or not. Then we start with declaring our variables and we specify the order in which our output will be stored in our file. Then we start with the looping again, and we use, as you see, we use formula for identifying how many marks will be enough for student to get A, to get B, and to get C. So we, as our range for A mark is 80 plus until 100, we use formula 80 minus total coursework, the same procedures with other mark. And again we showing our output, how it should be stored. And also, as you see, we use a formula here, A mark target multiplied by 2. It is because our coursework is 50%, but we need mark out of 100, so that's why we multiply by 2. And we close our input file and our recommended file. Let's see the output. So as you see, it shows the student ID, the total CV of the student, and how many marks would be enough for him if he or she wants to get A, B, or C. And we end our program with the return 0. Thank you for attention.